This is Precalculus Lesson 4-3, Evaluate Inverse Trig Functions. I will lead by saying this lesson assumes that you know your trig values of special angles really well. This speed sheet right here. Yes, you do not need to have 3.6 seconds per problem, but I do expect you to be able to, at least like 10 seconds per problem, know all of these really well. And if you don't, this lesson is going to be pretty hard because the homework tonight is going to look like this. Let me zoom out here. The answer key is attached to our homework assignment. This is not a speed sheet. This is just, I feel kind of bad for saying it, it's 100 problems, but you really need to know your inverse trig. Once you know these 100 problems, I think there's only like 17-ish different variations of the problem, then you're ready to go. This does not have to be done with speed because it's not too typical in AP Calculus, but you definitely know how to do it. It does come up in later classes like AP Calculus. So with that, let's go ahead and jump right in. Today's date is Thursday, January 28th. Thursday, January. I should use blue and zoom correctly. January 28th, 2021. I know I said I didn't want to record this lesson because there's going to be a lot of questions, but we've had so many snow days now that I'm getting worried. Our objective today is to find the principal values of specific angles with arcsine, arccosine, and arctan without a calculator. That's kind of a big difference from Khan Academy. I'm kind of not doing the Khan Academy thing of using a calculator for really, really hard problems. I'm giving you easier problems and expecting you to do it mentally. So, first of all, this word here, principal value in our objective, what does that mean? And there's a lot of different ways to define it, but I think the easiest way is just it's the smallest angle. And then I have a bunch of extra stuff, but just think of this. It's the smallest angle whenever I ask you the inverse function of sine. Again, it pairs with inverse functions, inverse trig functions. More specifically, it has to be the smallest angle that is in a function in a domain that is invertible. And I'll talk about that in a sec. So you remember last unit, unit 3, we talked about making functions invertible. That's what I want to do right now because this is inverse sine. Arcsine is inverse sine, undoing sine. So if I look at this sine function, and again, if you're writing all these notes by hand, you don't have to have this thing super accurate. I want you to take away the main point, which is this. We need to make this function invertible. Right now, this function goes on and on forever and ever as a sine wave, and I need to cut off its domain, and I want to get as close to this y-axis as possible. So it doesn't make sense to cut right here and right here. Yes, it makes it invertible because this horizontal line test passes, but that's not closest to 0. So what's closest to 0, and you probably can already see it, it's between here and here. It makes it invertible because it passes the horizontal line test. I can draw a horizontal line anywhere in that interval, and it only hits once. So I want to say that, I'll make this a little bit neater. I said neater. Mr. Sindel, use a straight line between here and here. That's where we can restrict the domain to. So we can say for the principal value, the PV for arcsine, or sine to the negative first, I call it arcsine in here because it's easier to type, is in this domain of between negative pi over 2 to positive pi over 2, including the end. So I have square brackets instead of parentheses. And if you're thinking of degrees, that would have been negative 90 degrees to positive 90 degrees. I'll put the little degree symbol. We're not going to really do degrees anymore. I'm going to try to stick to radians as close as possible because that's typically what upper level math classes will use as well, including the worksheet they have today. You'll notice that all the answers have pi in it because the instructions here say use radians. So between negative pi over 2 and pi over 2, and if you're thinking of a unit circle, another representation of the sine or inverse sine function, if I'm looking at the unit circle, between negative pi and over 2 and pi over 2 means I'm looking right here. So those are possibilities. This is the left-hand area is your no. Don't choose things over there. If I have the principal value, yes, the answer might be over on the left-hand side, but it won't be the principal value. What about for cosine? I can't do the same interval for cosine because if I go from here to here, it doesn't pass the horizontal line test. Look, it hits once, twice. That isn't passing. I have to shift my interval that I'm looking at. And I want to get as close to 0 as possible. And there are two options, really. I could go between 0 and negative pi, but you might as well just go with positive pi because positive numbers are a little bit easier. And indeed, that is how mathematicians consider the cosine function, the principal value of inverse cosine functions to be in this range between 0 and pi. And I'll write that down as well. So I'll say the principal value when you're looking at arc cosine to the negative first, is in this interval between 0 and pi. And for degrees, that's 0 and 180 degrees. What does that mean? That means if you're looking at cosine, you're going to be looking at something on the top. So this one was right on the unit circle, and this one is going to be, I can say top or up, I don't know, top. And I'm just going to write, no, not down here. I think that's pretty straightforward. Cosine is kind of like the sine function, except it's shifted either left or right by pi over 2 units. Tangent function is way different, and you might be worried. You're like, wait a sec, Mr. Sindel. In our speed sheet before, when we did this, we only had to do sine and cosine, and you're right. You only had to do sine and cosine, and I'm going to kind of up the level of difficulty here a little bit and make you do inverse tangent as well. They do come up less often than arc cosine and arc sine, but inverse tan or arc tan sometimes comes up in later math class as well, so I'll have you at least be exposed to it. So this is the graph of a tangent function. I don't know if anyone remembers what that looks like. And you'll notice that it is also periodic, except it has these vertical asymptotes. So that is a fancy way of saying, look, it never touches this line. It gets closer and closer to this vertical line, but it never touches it. And that vertical line is repeated here. It's repeated, oh, that line got a little bit crooked. That vertical line that it never touches, that asymptote, and I will write that down because you might be wondering how that is spelled. It's asymptote. The P is silent. Don't say this. This is silent. I can't tell you how many students have told me this is pronounced asymptote or something weird. It's asymptote. Don't pronounce the P. Yeah, so it does have these vertical asymptotes where it never touches over and over again. It's a little bit different, but it is still periodic. And again, the same question is, well, where do I draw my lines so it passes the horizontal line test? And it's pretty straightforward. I mean, it passes the vertical line or the horizontal line test if I just use the negative pi over 2 to pi over 2 interval. And indeed, that is exactly the interval that you look for principal value. So I think I'm going to go ahead and grab both these lines and make them orange, just to pop out a little bit. And I'll say when you're dealing with arc tangent to the negative first, you are looking at the interval between negative pi over 2 to positive pi over 2. And for those of us that like degrees, that's negative 90 degrees to positive 90 degrees. I have the little degree symbol. I noticed that the last one didn't have the degree symbol in the 0. Let me fix that. And that means it's the same domain, if you're looking at arc tangent, as a sine function. Sine function was also negative pi over 2 to pi over 2, which means it's on the right. So I'm looking over here. This is on the right. And over here, I'm going to write no, nothing on the left for principal value. In our next lesson, 4-4, I will allow you to come over here, but you will first need to find the principal value in order to find values that are not in the principal value area. Our zone, I should say, is region. All right, so now that I've talked about what it means to be a principal value, it needs to be in these intervals. That's the main thing that you just took away from the first, I don't know how many minutes of the lesson today. Now let's go ahead and actually practice doing these problems. So let me talk about what we were doing before. This is going forwards, what I would consider forwards with the trig values of special angles that we've been doing for our speed sheet. So going forwards, cosine of pi over 3, and then this is the mental picture that you get. You say, okay, pi over 3, where does that live? That lives... pi over 3 is basically 60 degrees. It lives right there, and then I make my right triangle comes down right here, and I say, okay, that's going to be a length of 1/2 and a length of square root of 3 over 2 for that 30, 60, 90 triangle. Cosine is asking about the x-coordinate. The x-coordinate is 1/2, and you spit out, okay, it's 1/2. Again, I was expecting you to do that problem in, what was my expectation? In 3.6 seconds was the hope. And you do this over and over again. That's going forwards. So I'll write up here, that was forwards. This over here is going to be backwards, which is a great way to emphasize you're going in reverse. It is the inverse operation. It is now arc cosine. And you might notice that 1/2 was the answer. Now 1/2 is the input. We have the output switching with the input, and that's what it means to go backwards. So let me talk about what this is even asking. It is asking in the principal value region, assuming that I'm trying to find the principal value. So in the principal value region for arc cosine, so arc cosine, if we remember, is on the top region up here. So in that area up here, what's going on? In this area up here, where do I have an x coordinate, because it's cosine, not sine, sine would be y coordinate, where do I have an x coordinate of 1/2? And I think I'm going to type that question because it's kind of an important question. Let's type that in green. Where do we have an x coordinate of 1/2 in the correct domain? Domain being the top half of the unit circle. And if I make this a little bit smaller, too small, there you go. That's the question that this is really asking. So when you see arc cosine, it's asking this. And if it was arc sine, it would be changing this to y. Arc tangent is something altogether different, which I'll talk about like in example 3, 4, and example 4. All right, so let's go ahead and think about this. The x coordinate of 1/2 means I am, first of all, not going left because that'd be negative 1/2. I'm going to the right, and I'm going to the right a distance of 1/2. And this distance of 1/2 intersects that unit circle up here, and you'd be like, oh yeah, the answer is 60 degrees. Oh wait, it's in radians. That's pi over 3 radians, and that is indeed the answer. Again, the simple way of explaining that is it's just you switch the input with the output and the input with the output. That's all it means to be an inverse function. And you're right, but figuring out what this question is really asking is a little bit hard. So again, asking x coordinate or y coordinate and figuring out where that value is. Let's try another one. So again, these are how I'm going to be asking the questions in the future. Find the principal value, so you know exactly what I'm looking for. It has to be in that correct range of values, or the domain of values, I should say, of arc sine of 0 in radians. Everything is in radians from here on out. All right, so let's go ahead and make our unit circle to figure out what this question is asking. Ooh, I have a circle tool. Let's go ahead and utilize that. Fill color, empty. Let's make it black. There's our unit circle. No, don't change. There's our unit circle. And I do want it to be like 1. There we go. So it's nice and thin. There's our unit circle. And 0 for sine means, and I'll type out our question again. This is asking, where do we have a, and then I'll change this to y coordinate. Y coordinate of, and then it's asking for 0 in the correct domain. So I can probably just make this come out that way. There, perfect. And, well, let's first remember what is the correct domain. And if you remember, that's on the right-hand side. It has to be somewhere on the right. And if you forgot, you can come up here. Oh, yeah, our arc sine, we have to be on the right-hand side for principal value. So come down here on the right-hand side. I'm going to scribble out all the stuff on the left-hand side. It can't be over there. It has to be somewhere over here on the right-hand side. So where do we have a y coordinate, or a height of 0? A height of 0, oh, there's only one spot, and it's right there. Again, if that left side was considered, then we might have said, oh, it's that spot right there. No, you're not allowed to be on the left. So it's that spot right there, and guess what that that is in radians? It's 0. So you can say arc sine of 0 is 0. And kind of, it's not mind-blowing or anything like that, I don't think. Let's try a slightly harder one. We'll box our answer too. Example number 2. Find the principal value of arc cosine with, ooh, this number looks familiar, right? That's a 30, 60, 90 triangle right there. That's a 45, 45, 90 triangle there. That's a, oh, what are those? Arctangent is weird, I know. We'll get there in a sec. All right, so let's go ahead and kind of copy paste this diagram up here down here. I'm going to get rid of those scribbles because that isn't the right area. So arc cosine needs to be on the top. So I'm going to go ahead and scribble out the bottom. It can't be anywhere down there. It has to be somewhere on the top. And I'm looking for an x coordinate because it's cosine. So I'm going to go ahead and kind of copy paste this same question. No, I don't want to write on that. I want to grab you. Copy paste the question. And now it's asking for the x coordinate because it's cosine, not sine. So where's the x coordinate of? And I'm going to probably just leave some space so I can actually write in that value. An x coordinate of, and it needs to be the square root of 3 over 2. That is negative square root of 3 over 2 in the correct domain. All right, well, where is the square root of 3 over 2, the negative square root of 3 over 2? Well, it's negative, so it goes to the left. And you'll notice that negative square root of 3 over 2 is the biggest out of the 3 different options between a half, square root of 2 over 2, and square root of 3 over 2. This is the biggest one, so it's farthest to the left, and it's right about there-ish. That is the x-coordinate. X is equal to the negative square root of 3 over 2. And you can even graph this on a calculator, like a graphing calculator like Desmos. If you type in x equals negative square root of 3 over 2, you will get this vertical line. And you'll notice that that intersects our circle. Let's use a different color here, right about there. And I'm noticing that I really needed to move this about there so that the triangle would be all right. This is not a 45, 45, 90. It is a 30, 60, 90. So I'm just trying to make that accurate. So that means that is what my angle looks like, and you'll say, oh yeah, that angle is about 30 degrees, or pi over 6 radians, which means I have to go pi over 6 radians minus from pi, or you'll just remember that's just 5 pi over 6. So the answer here is 5 pi over 6. 5 pi over 6. Final answer, and box it. All right, let's try another one before we hit arctangent. Principal value of arc sine of this value. So yet again, I'm going to grab our unit circle up here. Oh, I accidentally grabbed the question too, which actually I think I'll save it some time. A y-coordinate of a question is now not that. We'll give some room to write the correct thing I'm looking for. A y-coordinate of negative root 2 over 2 in the correct domain. Again, this is the correct domain. Sine needs to be on the right-hand side. Negative meaning going down, so somewhere in this fourth quadrant, and then the height is negative root 2 over 2, and you might just realize, oh yeah, whenever you have root 2 over 2, that's always a 45, 45, 90 triangle, so it's going to be right there. And then you have to remember, okay, what is that in radians? It's 7 pi over 4. So the answer here is just 7 pi over 4 radians, and I box my work. Again, once you start doing these over and over again, which is the reason I'm giving you so many problems, you get these faster and faster. You don't need to do them fast, but you do need to understand the logic and have that logic be nice and smooth. This is the hard part. Here we go. Example number 4. Find the principal value of arctangent of 1. Okay, so what is arctangent asking? The questions up here were always asking y-coordinate or x-coordinate. This is not asking x-coordinate or y-coordinate. It is asking a harder question, and I'll type out that question yet again. Paste. Where do we have and then this is kind of silly to say, I'll say a y divided by x coordinate of, in this case, 1. I don't need all that space because 1 is easy to type in the correct domain. And I know what you're thinking. You're like, what are you talking about, Mr. X or y divided by x? What does that mean? I'm going all the way back to, I don't know, Algebra 2 geometry. Whenever you first remember or learned about your basic trig, it should have been geometry if I was doing my job correctly. If I have, let's just choose a random point to make a triangle. If I have some angle here and I say, what is tangent of that angle theta, then your answer is, oh, you're using SOHCAHTOA. SOHCAHTOA. That's what I'm deriving. Oh, it's O over A. And what is over A? It's opposite over adjacent. All of these were always divided by hypotenuse, which is why it was so easy, because our hypotenuse was always 1. So really what I was over in here, what question I was asking over here is, what is the y divided by 1 coordinate? Or what was the x divided by 1 coordinate? Those were easy, and these fractions come from SOHCAHTOA. But now the denominator is not the hypotenuse, it is the adjacent. And guess what? The adjacent is the x direction, which is why I have x in the denominator. I am, again, just re-emphasizing, y over x comes from opposite divided by adjacent, from the definition of SOHCAHTOA. Okay, and that's harder to think about, but if my answer is 1, that means my opposite and adjacent are the same number. I'll let that sink in because it's kind of interesting to think about. If I have any number, 2 divided by 2, it's equal to 1. Any number, 100 divided by 100 is equal to 1. I'm not going to kick a dead horse here. You guys know the same number divided by itself is 1, which means the x and the y have to be the same. If I'm thinking about this in terms of a triangle, which is the root word of trigonometry, tri, right? If I'm thinking about this as a triangle, that means my triangle has the y direction and the x direction the same length. What triangle has the same length? Oh, a 45, 45, 90 triangle has the same length. And notice I said positive 1. If it was negative 1, then I would have this dimension or that dimension be negative. And because tangent is on the right-hand side, like sine, it would just be a negative y coordinate. But I'll get to that when I get to the negative one down here. But for now, keep things simple. It's a 45, 45, 90 in the first quadrant, and that means that this point right here on the unit circle has an angle measure of pi over 4 radians. Pi over 4 is our final answer. Again, let me draw a picture because I didn't actually draw the full picture. I'm essentially sticking this triangle into our diagram. That triangle in our picture lives right here, boom, where this dimension and this dimension are the same, and that unit circle, or that angle measure right here, is pi over 4 radians. All right, and then the really difficult one. Here we go. So very similar to the last questions, it's going to have the same type of question. If I grab this and copy paste it, this is asking the question, where do we have a y divided by x coordinate of, and it's going to be negative root 3. So I can write negative root 3. It looks a little bit weird when I type it, but I think you guys get the gist. And again, the correct domain means on the right-hand side. So we know we are on the right. All right. Domain for our arctan function for principal value somewhere on the right-hand side. We'll write no over there. So negative. If it's negative, that means one of the dimensions has to be negative. Everything in the top is positive, so we have to be somewhere in this fourth quadrant in order for this to be a negative, because it's, again, y divided by x. One of them has to be negative. In this case, the y is going to be negative down here in this fourth quadrant. So again, I can cross things up here. This is the positives for our tangent, and this is going to be the negatives for our tangent, for, I guess I should say, arctangent. So let's go ahead and draw a picture of what's happening. This is saying that I have a fraction. My fraction is really saying negative square root of 3 is the same thing as a fraction, because we need to make it y over x. We have to have this as a fraction. Our fraction is negative root 3 over 1. And I think having the negative in the numerator is even more important, not just out in front, because technically I told you the y coordinate should be the negative, because we're restricted to the positive x's. Everything on the right-hand side. We can't have this x coordinate, this bottom denominator, be a negative. And we basically solved it, except this square root of 3 doesn't look like any piece of our special right triangle. You might remember it should be square root of 3 over 2 or something like that, right? So why do we have square root of 3? And this is the reason. Let me go ahead and draw you a picture. If I draw a picture, I should have a length down here. This is the answer, but let me explain why. So I'm going to do, let me try to color code this to make it easier. Let's make the y coordinate blue, and let's make the x coordinate orange, which means that this 1 should be orange. So this, on a unit circle, this length of this 30, 60, 90 triangle should be negative square root of 3 over 2, and this length up here in orange should be positive 1/2. Okay, well, what happens when I do y divided by x? When I do this blue negative square root of 3 over 2 divided by this orange 1/2. Does that actually turn into negative square root of 3? If it doesn't, then this is the wrong answer. And it does. Let's show you why. So if I do, again, color coding this, negative square root of 3 over 2 divided by, and I'm doing this division symbol because it will make things a little bit easier, divided by 1/2, instead of doing a giant fraction here. Well, when you have a fraction divided by a fraction, you keep it, change it, flip it, keep it. So let me do black here. Keep it is going to be negative root 3 over 2. Change it to a multiplication from division and flip it to 2 over 1. And look at this. The 2's cancel each other out, and I'm left with negative square root of 3 over 1, which is this fraction, which I can simplify even further to just say this is negative root 3, which is exactly what that input for our arctangent function was asking for. So this location on the unit circle is correct, and that is 300 degrees, or that is 5 pi over 3 radians. And we're doing everything's in radians, so this is 5 pi over 3. Final answer, and box it. Wait a sec, that's not correct. While that angle is 5 pi over 3, you might remember that our domain up here was between negative pi over 2 and pi over 2. 5 pi over 3 is too big. It is bigger than pi over 2. We need to make it a negative angle, which means this is actually easier to memorize. Instead of saying 5 pi over 3, let's say no, wrong domain. Wrong domain. This needs to just be negative pi over 3. Negative pi over 3. That is in the correct domain. It does have to match. Even though it's on the right-hand side, if it's negative, I have to write it as a negative. Same thing with a sine. I should have given an example problem with sine. Oh, I did! Oh my god, I didn't catch it. I am so sorry. This is my first time teaching this lesson, I should point out. This is not 7 pi over 5. Wow, we made a mistake. This is not correct. This is wrong domain. This should just be negative pi over 4. Negative pi over 4, because it needs to be a negative. So I'll box that one. I'll get rid of the box up here. That 7 pi over 4 is the wrong domain. Sorry about that. 5 pi over 6, was that at least correct? Okay, that was correct because that needs to be in the top, and 5 pi over 6 is less than pi. Okay, all of our domains now check out. Sorry about that mistake. This needs to be negative pi over 3. All right. I'm not going to leave you there. I will show you the completed notes if you want to take a look at them, or maybe you skipped to the video at the very end just to say you copied down the notes. I have a feeling I'm going to be going over this again with you in person in class. I also want to do some of the worksheet with you and talk about how I think about each of the problems, especially with these arctangents, because I know they can be difficult if you've never seen them before. So let's go through a few of these problems in the worksheet. I feel like since there's so many, it's okay if I give you a few freebies, right? So I'm going through the logic for each of these. Let me zoom in so give me as much room as possible. So arc sine of -1, that's asking where do I have a y-coordinate of -1? So I give myself my unit circle. My y-coordinate of -1 means I'm somewhere down here, which is at the very end of the unit circle. You'll notice the unit circle is a length of 1, so there's only one spot that has a length of -1, and it's that spot right there. You will remember that our domain for arc sine has to be on the right-hand side, and that point is on the right-hand side. This answer is not 3 pi over 2, all right? 3 pi over 2. Yes, that's the point that we memorized, which is not in the domain. We just say negative pi over 2 in this case, because we use positive and negative numbers when we're dealing with arc sine. And that's our final answer. All right, how do I do arc cosine of negative root 2 over 2? Again, I always think on my unit circle. So I have negative root 2 over 2, and this is going to be the x-coordinate. I'm somewhere up here. I have to be on the top region for arc cosine. Negative root 2 over 2, that reminds me of a 45-degree angle, and it's negative, which means it's somewhere in this second quadrant, so I must be right there. That coordinate is 3 pi over 4, and I'm done. 3 pi over 4. I think that arc cosine for all of us is going to be easier than arc sine and arc tangent, just because we don't have to worry about, oh, it should have been a negative. This one is always going to be positive for arc cosine. And I box it. Do I get an arc tangent in here eventually? Okay, I'm eventually going to skip to an arc tangent because I don't know why those are not showing up very often. I think they probably are just kind of lower down in the worksheet. Again, I just hit a randomize button on this, so I didn't choose the order here. Let's do arc cosine -1, then I'm going to jump to a tangent. So arc cosine of -1, this is asking where do we have an x-coordinate that is -1? And there's only one x-coordinate in the entire unit circle that is -1, and it's right there. And you'll notice, yes, that is in the top region because you include the ends here. I had a square bracket, remember, for our lesson. That angle right here is pi. And final answer, box it. Let's jump down to a tangent, arctangent. I see one right here. Okay, arctangent of 0. How do I do that? So again, unit circle. This is asking for a y divided by x coordinate that is 0. So if my y divided by x is 0, that means y must be 0. X cannot be 0. X can be literally anything it wants to be, but because it's on a unit circle, it's going to be 1. If the y coordinate is 0, though, then that means the y coordinate can either be here or here. That's a y coordinate of 0. Remember that for arctangent, we are only allowed to be on the right-hand side, which means our answer is that point right there. Our answer is 0 radians. And if you just want to memorize arctangent of 0 is 0 and arcsine of 0 is 0, that's great. I want to jump to another arctan because those are kind of tricky. We did negative square root of 3. Let me just rehash the logic of square root of 3, and I'll do one more, and then I think I will end, unless I discover something new while I'm doing this. Again, I think of the unit circle. This is going to be the y over x. That is going to be root 3. The only thing that makes sense is having a square root of 3 over 2 in the numerator and a 1/2 in the denominator, which means, and everything is positive. So again, when I'm doing arctangent, it has to be on the right-hand side. If everything is positive, I am going to be somewhere in this first quadrant. So if even better, somewhere up here, and I want the y-coordinate to be square root of 3 over 2 and the x-coordinate to be not so big, which means I'm talking about this angle right here. That means our x-coordinate is 1/2 and our y-coordinate is pretty big. Again, square root of 3 over 2 is always the biggest one that we have to choose from, aside from 1, I would guess. And this angle right here is pi over 3. Let's find an arctangent that has a fraction in it, because I don't think I did one of those. Ah, there we go. This one down here. I'm looking at the negative one. I think this is like the hardest type of question I can ask. All right, so again, unit circle. I have to be somewhere on the right-hand side, and because, I don't know why I chose red there, because I am negative, you know that I'm going to be talking about this fourth quadrant down here. So really, I'm talking about somewhere down here. Okay, and this is asking the question, where do I have a y divided by x coordinate of negative 1/3? Well, the negative, I already know what's happening with the negative. The negative is going to be applied to the y. So I'm going to have a negative in the numerator and something positive in the denominator. And the only thing that makes sense, the square root of 3 is in the denominator, so I must have a square root of 3 over 2 in the denominator, and I must have a 1/2 in the numerator. These two always get paired together, just like root 2 over 2 and root 2 over 2 itself gets paired with itself. That's the size of those two special right triangles. So if that's the case, then my y-coordinate, I go down 1/2, and my x-coordinate, I go right square root of 3 over 2, which is right about there. And that angle, you might think 11 pi over 6, and you're correct, except this needs to be negative. So I'll write 11 pi over 6, which is incorrect. That's too big. We just do a negative angle. We'll just say negative pi over 6 and box it. All right, I know I haven't done all 100 of these problems. They do take a little bit of time, but you get really fluid the more problems you do. That concludes Notes 4-3. Good luck. Please message me with questions, and hopefully I'll see you in person or on Zoom or somewhere to answer the many questions that I anticipate coming from this lesson.